Hi everybody, in this video we're going to talk about two-way tables. A two-way table is a rectangular array containing data. So here you see a rectangular array. The data is organized by two categorical variables, one for the columns and one for the rows. So what is a categorical variable as opposed to just a regular variable? Well, a regular variable like x or y might take on a wide range of values. So for example, x might be 3 if you have some equation or you're doing some problem where x is the variable, then x might be 3 or x might be -8 or x might be 4220.6 or x might be -4/9 or whatever it is. So there's a wide range of values that variable can take on. But with a categorical variable, there are only a few options for the variable. So for example, in this two-way table, we have size over here, and the size could only be small, medium, large. That's it, okay? And we also have another categorical variable, item, and item can only take on the value of fries or shakes. Okay, so we either have fries or shakes, so those are the only items we have, and the only sizes that we have are small, medium, and large, okay? Nothing else. Now, let's go ahead and use this two-way table to answer some problems. So what I'm going to do is I'm going to try to get the table. Oh, well, anyway, let me read this first of all. The following two-way table shows frequencies related to how many times an item of a particular size was ordered at a fast food restaurant in a given week. So frequency just means how many times something happened, okay? So I want this to be up here now. And I want my questions to be down here. Okay, so that's good. So let's use this frequency table. Can I squeeze that in also? No, I don't think so. All right, so just remember this is about... This two-way table has to do with the number of times that certain items of a particular size were ordered at a fast food restaurant in a given week. All right, so how many large shakes were ordered? Well, it's not hard to figure that out. Just going to go to the two-way table here, and this column here has all of the large items that were ordered, and we can see that 82 large fries were ordered. And then if we go down here, we see that 101 large shakes were ordered. So the answer to this question is 101. There were 101 large shakes that were ordered. How many medium fries were ordered? Well, we see medium here, we see fries over here, and where do they meet? They meet at this number, 237. So 237 medium fries were ordered. Okay, next question, pretty simple. How many fries were ordered? So this question is not asking us how many small fries or medium fries or large fries. It just says how many fries. So we're talking about all of the fries, regardless of whether they were small, medium, or large. Okay, so we want the total number of fries. Okay, so we'll look at fries over here, and we see that over here in this column, this gives us the total for the number of fries that were ordered and also for the number of shakes that were ordered, but we don't need that right now. We just need the total number of fries, which is 514. So if you add these three numbers together, 195 plus 237 plus 82, you would get 514, and that's the total that we're looking for. Okay, how many small items were ordered? So this time we don't care if the item was in order of fries or a shake. We just want to know if it was small, okay? So how many small items were ordered? So, well, there were 195 small fries. There were 73 small shakes, but we don't care if it was fries or shakes. We want the total. So we're going to look down here, and here you see there's another. So all of these rows have been totaled over here on the right, but then these columns have been totaled down here. And we can see that the total number of small items is 268. So if you add 195 and 73, then you get 268. That was the total number of small items ordered. What is the total number of orders of all items of any size? So everything. And that answer would be right here in the corner, right? So there were 514 fries ordered, regardless of if they were small, medium, or large. And there were 264 shakes which were ordered, regardless if they were 73 or 90, regardless if they were small, medium, or large. All right, so the total here, if we add 514 and 264, we would get 778. That's the total number of everything that was ordered, whether it was a fries, shake, or if it was small, medium, large, everything, just add it all together, we get 778. And this number, by the way, is the same number that you would get if you added these three numbers over here. So there was a total of 268 small items, 327 medium items, 183 large items. If you add these three numbers together, you would also get 778. Okay, you're just organizing them by size, and over here you're organizing them by item, but you're talking about the same stuff, right? So the totals should come out to be the same. So the grand total, if you will, is 778. All right, next question. How many more small shakes were ordered than large shakes? Well, let's see over here. So small shakes, how many small shakes were ordered? That would be this number 73. And how many large shakes were ordered? This would be 101. Oh, really? You know what I should say? Let me change the question, because there are actually more large shakes than small. So I should say how many more large shakes were ordered than small shakes. So to figure that out, we would subtract. So we would do 101 minus 73. Which is 28, right? But let's just practice subtracting. So 101 minus 73. Can't take 3 away from 1. Can't borrow from 0. Borrow from the 1. That becomes a 0. Put a 1 here. Borrow from the 10, that becomes a 9, put a 1 here, and then we get 11 minus 3 is 8, 9 minus 7 is 2. Okay, so there were 28 more large shakes ordered than small shakes. How many more medium items were ordered than small items? So now since it didn't say, this question had nothing to do with fries or shakes. We're just talking about all of the small items and all of the medium items. So we're going to look down over here in the totals. The total number of medium items was 327. The total number of small items was 268. So we're going to do 327 minus 268. Can't take 8 away from 7. Borrow from the 2. That becomes a 1. Put a 1 here. 17 minus 8 is 9. Can't take 6 away from 1. Borrow from the 3. Becomes a 2. Put a 1 next to here. 11 minus 6 is 5. 2 minus 2 is nothing. So we get 59. So there were 59 more medium items ordered than small items. Okay, I think I have a couple other questions here. How many small and medium items were ordered? Okay, so, well, there were 327 medium items ordered. There were 268 small items ordered. Again, whether they were fries or shakes, it doesn't matter. There were 268 small items, 327 medium items. How many small and medium items were ordered? Well, to answer that, we would add them up. So 327 plus 268, 7 plus 8 is 15, carry the 1. Because 1 plus 2 is 3, plus 6 is 9, 3 plus 2 is 5. So 595 small and medium items were ordered. What is the, excuse me, what is the most popular item? Okay, so to figure out what the most popular item is, what we want to do is go over to these totals over here, which are the totals of the items, as opposed to down here, which are the totals of the sizes. So there were 514 fries which were ordered, and 200, not individual fries, but orders of fries, and 264 shakes which were ordered. So it looks like fries are more popular than shakes. So the most popular item is fries. What is the most popular size? So now we're going to go down here to these totals of sizes, right? So there were 268 small items which were ordered, 327 medium items, and 183 large items. So the biggest number there is 327. So it looks like the medium size is the most popular size. All right, now let's get into percentages here. What percent of all the items ordered were fries? Well, all of the items ordered, the total of everything is 778. And if I want to know the percent of the items which were large, then I'm going to have to look at the total number of large items which were ordered, which is over here. That's 183 large items were ordered. 82 of them were fries, 101 of them were shakes, but that doesn't really matter. The total number of large items was 183. The total number of items altogether was 778. So what percent of all the items, what happened here? Oh, I'm looking at the wrong, oh, wait. This question was what percent of all items ordered were fried? Okay, okay, so I went out of order here. Let me do this question first. What percent of all the items ordered were large? Oh, well, there were 183 large items ordered, 778 total. So what we're going to do is we're just going to get our calculator over here, and we're just going to do 183 divided by 778, which was the total of everything. All right, hang on a second. Okay, so 183 divided by 778 equals 0.23521, blah, blah, blah. So you know what, let's round that to the nearest tenth of a percent. So what does that mean? I'm not going to, if I just took this decimal over here and rounded to the nearest tenth, well, this is in the tenths place, and then this is a 3 over here. If the next digit over is a 0, 1, 2, 3, or 4, then this digit stays the same. If the next digit over is a 5, 6, 7, 8, or 9, then this digit gets bumped up 1. This is a 3, so this would stay the same. So if I wanted to round this to the nearest tenth, then I would say that this is approximately 0.2. But what I want to do is I want to round this to the nearest tenth of a percent. So that means that first I'm going to move the decimal point 2 spaces to the right, 1, 2. So now my new decimal point is over here, and this number, the 5, is in the tenths place. So the next digit after the 5 is a 2, which means that this 5 is going to stay the same. So rounded to the nearest tenth of a percent, that would be 23.5%. So when you're rounding to the nearest tenth of a percent, or hundredth of a percent, or thousandth of a percent, or whatever it is, move the decimal point 2 spaces to the right first, and then round. Okay, so we would get rounded to the nearest tenth of a percent here. We would get 23.5%. And then I skipped this question over here. What percent of all the items ordered were fries? So to answer this question, I'm going to look at the total, this column over here, which tells me the totals of the items. So there were 514 fries which were ordered. So what percent of all the items were fries? Well, all of the items of any size, of any type, were 778. That was everything that was ordered. 514 of them were fries. So we're going to do 514 divided by 778. And that's going to give us 0.660668838, blah, blah, blah. Okay, so if I want to round this to the nearest tenth of a percent, then I would move this 2 spaces to the right, 1, 2. So now the decimal point is here. What's in the 10th place here is a 0. But if I look at the next digit over, that's a 6. Remember, anything 5, 6, 7, 8, or 9 is going to bump this up 1. So 0 plus 1 is 1. So we would get 66.1%. That's rounded to the nearest 10th of a percent. 66.1%. What percent of all the fries were large? Now you have to be careful here. For the last two questions over here, we looked at this number, which was the total of everything. That was the grand total. Okay, that was fries, shakes, small, medium, large, everything, right? But now in this problem, it's asking me what percent of all the fries were large. So for this problem, I'm not interested in the shakes. This total over here also includes the shakes that were ordered. But I'm not interested in the shakes for this problem. I'm only interested in the fries. I want to know, out of all the fries which were ordered, what percent of them were large. So again, this number over here is the total number of fries which were ordered. Now, how many of these fries were large fries? That would be 82. So 82 of the fries were large fries. So what I'm going to do for this problem is divide 82 by 514, not by 778, because that includes the shakes. We don't care about the shakes for this problem. Okay, so we're going to do 82 divided by 514, which is 0.159 blah, blah, blah. So what we're going to do here is move this 2 spaces to the right, 1, 2. So the new decimal point is over here. This is in the 10th place. Again, let's just round all of these to the nearest 10th of a percent. The next digit over is a 5, which means this has to get bumped up by 1. So 9 plus 1 is 10. How do I put a 10 here? Now, there are some people who are going to say, well, that would be 15.10 like that. No, that's wrong. We're not going to do that. What we're going to do is, if this 9 is getting bumped up to a 10, then we're actually going to put a 0 in the 10th place, which is what we were rounding to. And then this also gets bumped up by 1, so that's going to become a 6. So rounded to the nearest 10th of a percent, we're going to get 16.0%. Okay, what percent of all the large items were fries? This question is not the same as this question. You have to be careful. If back in this question, we were asked what percent of all the fries were large. So first we had to find the total of the fries. Here's fries here, and here's the total number of fries, which was 514. And then see how many out of those 514 were large, which was 82. For this problem, we're asked what percent of all the large items were fries. So for this one, first we're going to find the total of all the large items. So here's the large column. Here's the total number of large items, including the fries and the shakes, which is 183. Next, we're going to find how many out of those 183 items were fries. So that would be 82. 82 out of these 183 large items were fries. So to answer this question, we're going to have to do 82 divided by 183. Again, we're not going to be dividing by the grand total over here because that includes items which were medium or small. We're only interested in the large items here, which was 183. So we're going to do 82 divided by 183. And we would get, let's round this to the nearest 10th again. Decimal, move that over 2 spaces. So in the 10th place now we have the 8. The next digit over is a 0. So this 8 is going to stay the same. Remember, anything which is 0, 1, 2, 3, or 4, the digit that you're rounding to stays the same. So this 8 is going to remain an 8. Okay, if this had been a 5, 6, 7, 8, or 9, then this 8 would have been bumped up 1 to a 9. But it was a 0, so we're going to keep it the same. And our answer for that problem is 44.8%. Okay, next question. What percent of all the items ordered were small or medium? So now we are looking at the grand total again. Okay, all of the items that were ordered, whether they were fries, shakes, small, medium, or large. So we're looking at this grand total over here. That's going to be our divisor. Okay, that's what we're going to be dividing by. Now, what is going to be our dividend? What's the other number that we need to divide by 778? Okay, so what percent of all the items ordered were small or medium? Well, what we're going to do is we need to add up the small and the medium orders. Again, we don't care for this problem. We don't care if they were fries or shakes. So we're going to look at the total number of small items, which was 268, and the total number of medium items, which was 327. We're going to add those up, okay, and that's going to give us 595. Did I do that before? I might have. So there were 595 items which were either small or medium. Now we're going to take this number and we're going to divide that by 778, which was the grand total. Okay, so what am I looking for? So 595 divided by 778. Now let's round that to the nearest tenth. Okay, there's the decimal point. Here's the digit we're rounding to. The next digit over is a 7, which means this is going to get bumped up 1. So that 4 is going to become a 5. So 76.5% is our answer. Out of everything that was ordered, 76.5% of everything that was ordered was either a small or a medium item. Okay, last question here. What percent of all the items ordered were not large? Well, there are a couple ways that we can answer this problem. We could look at all the large items, which is 183, and then divide that by 778. So 183 divided by 778 equals 20. So that would be, if I round that to the nearest tenth, that would be 23.5%. But 23.5%, that's the percent of all of the items which were large. If we want to know the percent of all of the items which were not large, then we have to subtract that from 100, because 100% is everything, right? So this is all of the large items. If we do 100%, I'm not going to type in 100%, just 100 minus the percent which was large, then that's going to tell us the percent which was not large. So 100 minus 23.5 equals 76.5. All right, so 76.5% is all of the items which were not large. And is it a coincidence that this answer turned out to be exactly the same as this answer over here? No, that's not a coincidence. There's a good reason that happened. Because if something is not large, then it's either small or medium, right? And we already answered what percent of all the items were either small or medium. That was 76.5%. So it's not surprising that the answer to this question is exactly the same. Okay, all right, anything that's not large is either small or medium. So really, these questions are the same. They're just worded differently, right? Okay, so the next thing that we're going to do is we're going to look at the same table again, except with some of the entries removed. And we're going to ask ourselves, is it possible to reconstruct the original table that we had to begin with? All right, so if for whatever reason some of the data is lost, is there's still enough data for us to figure out what numbers were maybe removed by accident. Okay, and actually there is enough there's not always enough information. If too many entries get removed, then you won't be able to do it. But in this example, there is enough information for us to reconstruct the whole thing. So let's say I wanted to figure out how many small fries there were, and I don't remember what the number was from before. Well, I could figure that out by taking the total number of fries, which was 514, and since I know that this plus this plus this must add up to 514, then I can figure out what this would be by taking 514 and subtracting 82 and then subtracting 237, or by subtracting 237 and then subtracting 82. So let's do that. So 514 minus 82 minus 237 equals 195. Okay, let's see if that answer makes sense. Again, this plus this should add up to 514. So let's see if it does. 195 plus 200, how do I go back? I don't know. Oh, there we go. Plus 237 plus 82 is equal to 514. And it should also work out that this plus this is equal to 268. So 195 plus 73 is equal to 268. Okay, now another way that we could have figured that out is to do 268, which should be the total of this, and subtract 73. That would also give us the missing number. So 268 minus 73 would also be 195. Okay. Let's see. Now, what about this one over here? Is there any way that we can figure that out? We can take this 327 and subtract 237. That would tell us what this has to be, because this plus this has to add up to 327. Okay, so 327 minus 237 equals 90. All right, now what about this one over here? For this one, we could get this one, which should be the total number of large items which were sold. So we can add the 82 large fries to the 101 large shakes, and that should give us the total number of large items altogether, which should be 183. Okay, just this plus the 82 plus 101 is 183. And what about the grand total? Well, to get the grand total, we would add the total number of fries and the total number of shakes, or we could add the total number of small items, the total number of medium items, and the total number of large items. Both of those addition problems would give us the grand total. All right, so let's do 514 plus 264. That's 778. And again, I think I said this earlier in the video also, but we could have also done 268, which is the total number of small items, plus 327, total number of medium items, plus 183, which is the total number of large items, and that also gives us 778. Okay, so we were able to, even though some of the entries were deleted here, we were able to reconstruct the entire table, which was the same table that we had earlier, okay, just by using a little bit of logic there, right? If this is the total number of fries, then this has to be 195, because then they would add up to 514, and so on. Okay, so what else are we going to do? Now, what if, let's say I have let's do a different two-way table over here. So this table is another frequency table. A frequency table is just the table that tells you how many of something. Okay, so for example, this is a two-way table that has to do with the level of difficulty of all of the holes in two different golf courses. So I don't know if you're a fan of miniature golf. I like miniature golf. Let's say that we have one miniature golf course which is called Goofy Golf, and we have another miniature golf course which is called Perfect Putt. And this table tells us, for example, there are 6 beginner holes at the Perfect Putt golf course. There are, just as another example, there are 4 intermediate, which is like medium holes at the Goofy golf course, and there are 10 advanced holes at Goofy Golf, okay, for advanced miniature golf players. There's a total of 22 Goofy Golf holes at Goofy Golf. There's a total of 28 holes at Perfect Putt. You might be thinking to yourself, wait a minute, aren't miniature golf courses supposed to have 18 holes? If that worries you, then you're taking this way too seriously. All right, so this is a frequency table which gives us information about how many of a certain level of how many holes of a certain level of difficulty are at each of these 2 golf courses. Now, what if we wanted to turn that into a relative frequency table? So let me just write the words here. This is a two-way table that gives us the frequencies. So this would be a two-way frequency table. And this over here, what we want to do is we want to take this frequency table and turn it into a two-way relative frequency table. Now, when we do relative frequencies, we're comparing the frequencies to the grand total. So, for example, I know that 8 of the holes were beginner holes at the Goofy Golf course, and there were 50 holes all together. So if I do 8 divided by 50, where's the thing here? 8 divided by 50, actually there's an easy way to do that. We'll get 0.16. If you just do 8 times 2, actually it's pretty easy to divide something by 50. You basically take that number and multiply it by 2, and then put that after the decimal point. So for example, 8 times 2 is 16, and you can see here when we did 8 divided by 50, we got 0.16. So why does that work? Well, because 8 over 50, if I multiply the numerator and the denominator by 2, then the denominator becomes 100, and then I get 16 over here, and 16 over 100 is just 16 hundredths. Okay, so that's why that little trick works. So basically for all of these, what I'm going to do just to get the answers quickly is I'm going to multiply by 2 and then just put that number after the decimal. But really what I'm doing here, in general, if you want to get the relative frequency for something, you just take the number and you divide it by the grand total over here. That's all you need to do. So over here we would get 0.16. Okay, and relative frequencies are usually written in decimal form, like I just wrote it over here. But you could also say that that number is 16%. So 16% of all of the holes are beginner holes at the Goofy Golf course. Okay? So we're taking this number over here, which is just the frequency, how many beginner Goofy Golf holes are there, and we are comparing that to all of the holes. So we're saying 16% of all the holes are beginner holes at the Goofy Golf course. Okay, now there are 6 beginner holes at the Perfect Putt golf course. If I want to compare that to all the holes, then I would do 6 divided by 50 just to figure out what proportion of all the holes are beginner holes at the Perfect Putt golf course. So 6 divided by 50 is 0.12. You can see I could have gotten the same answer just by doing 6 times 2, which is 12, and putting that after the decimal point. So it's a little trick for dividing something by 50. All right, so this one, anyway, so over here we got 0.16. This one would be 0.12. So 12% of all of the holes are beginner holes at the Perfect Putt golf course. 14 divided by 50 is going to be 0.28. 4 divided by 50 is going to be, well, I should say it's not 0, so 4 times 2 is 8, right? But it's not going to be 0.8, it would be 0.08. Okay, 8/100ths, not 8/10ths. All right, anyway, you can do it in a calculator. So just take the number and divide it by the grand total over here. That's all you have to do. And relative frequencies are usually written in the form of a decimal as opposed to a percent, so you don't even have to move the decimal point 2 spaces to the right to get it into percent form. Just take whatever answer you get on your calculator, and that's your relative frequency. Okay, 7 divided by 50 would be 0.14. 11 divided by 50 would be 0.22. 10 divided by 50 would be 0.20, or just 0.2. 15 divided by 50 would be 0.30, or just 0.3. 25 divided by 50 would be 0.50, or 0.5, which makes sense because 0.5, that's 50% or a half, right? And 25 is half of 50. All right, so 22 divided by 50, that's going to give us 0.44. 28 divided by 50 would be 0.56. And 50 divided by 50 would just be 1. So in a relative frequency table, the grand total over here is always going to be 1. Okay, which makes sense because 1 as a percent is 100%. If we take the decimal point over here and move it 2 spaces to the right, just if we wanted to turn it into a percent, then we would put zeros in these blank spaces over here is the new decimal point. So 1, the number 1 as a percentage would just be 100%. Well, that makes everything. And that makes sense because this number in the bottom right corner over here is supposed to be the grand total. So this number is everything that we have, right? Over 50 is all of the holes all together, whether they're at Goofy Golf or Perfect Putt, and whether they're beginner, intermediate, or advanced. This is all the holes that there are, so it makes sense that this number here should be 100%. But in decimal form, instead of percent form, that would just be 1. Okay, and usually the decimal point isn't even written. So this number in a relative frequency table, this number in the bottom right-hand corner is always going to be 1, okay? And you could also see that 0.28 plus 0.22 plus 0.5 is equal to 1. So it all makes sense. 0.44 plus 0.56 is again equal to 1, right? Just like all of these numbers should equal the grand total over here, and all of these numbers should also equal to the grand total. You can add these numbers together to get this grand total. And it's the same thing if I just want to pick some other row or column. So for example, there are 4 intermediate holes at the Goofy Golf course. There are 7 intermediate holes at the Perfect Putt course. The total number of intermediate holes is 11, 4 plus 7. It works the same way over here in the relative frequency table. So if 0.08 is the relative frequency, or if I say that as a percentage, 8% of all of the holes are intermediate Goofy Golf holes, and there are 14% of all of the holes are intermediate Perfect Putt holes, then 8% plus 14%, or 0.08 plus 0.14, is 0.22, or 22%. So 22% of all of the holes are intermediate holes, okay, whether they're at Goofy Golf or at Perfect Putt. All right, so you can add the numbers in a relative frequency table to get the totals, just like you would add the numbers in just a normal frequency table to get the totals. All right? Okay, so we converted over here, we converted this relative frequency table into we converted this frequency table, which just tells us how many of something there are, into a relative frequency table, which tells us what percent of the whole is this number, or what percent of the whole is this number, and so on, except those percentages are usually written as decimals. What if we wanted to go the other way? And so what if we wanted to... Oh, that's not what I want to do yet. Okay, what if I wanted to take this relative frequency table and convert it into a frequency table? Okay, well, how could I take these numbers and take this relative frequency table and convert it back into the frequency table that I had before? If somebody gives you a relative frequency table and asks you to convert it into a frequency table, is it possible to do that? The answer is no, it's not possible to do that unless they tell you what the grand total is supposed to be. So this just tells me over here, or let me pick a different number. So for example, this number over here, 0.16, that tells me that 16% of all of the holes are beginner goofy golf holes. Now I cannot take that number and convert it into a normal frequency unless somebody tells me that the grand total is what the grand total is supposed to be. So if I'm given the relative frequency table all by itself, then I can't convert it into a frequency table. But if somebody tells me the grand total should be 50, let's say, just like it was before, then I can take that number, and it's actually very easy to convert these back into frequencies. We just take all of these numbers and multiply it by the grand total, which we must be given, and then that tells us what the frequencies are. So let's do that. So it's just like what we're doing, but in reverse, because multiplication is the inverse of division, right? We used division to get from here to here. We're going to use multiplication to get from here to here, and we just have to remember that the grand total is supposed to be 50. So if 16% of all of the holes were beginner goofy golf holes, and I know that there are 50 holes as the grand total, then we'll just do 0.16 times 50, and that will give us 8, which is the number that we had earlier, right? If we do 0.12 times the grand total, which was 50, so 12% of the 50 holes that there were altogether were beginner holes at the Perfect Putt golf course. So 0.12 times 50 is equal to 6, which is the number that we had earlier. So all you need to do is take these numbers here and multiply them by the grand total, and the grand total is not given to you in the relative frequency table. That's why you just have to know what the grand total is. Either you know it or somebody tells you what the grand total is, and then it's easy. Then you just take that and then multiply all the numbers by the grand total. All right, so 0.28 times 50 would be 14. 0.08 times 50 would be 4. 0.14 times 50 would be 7. 0.22 times 50 would be 11. Again, let's do over here, 1 times 50 would be 50, right? So if I know that the grand total is 50, I know that 22% of the 50 were intermediate holes, then how many intermediate holes were there? So we just do 0.22 times 50, and that tells us there were 11 intermediate holes, okay? All right, 0.2 times 50 is 10, 0.3 times 50 is 15, 0.5 times 50 is 25, 0.44 times 50 is 22, 0.56 times 50 is 28. Okay, so these are all the numbers that we had to begin with, and all we needed to do to get those numbers is take these numbers in the relative frequency table and multiply them by the grand total. Okay. Now, let's take this relative frequency table here, where some of the entries have been deleted, and let's see if we can reconstruct what this relative frequency table should be. And we're also going to pretend that we never saw this frequency table, so we can't use the frequency table to help us with the relative frequency table. This is for later. Is it possible to reconstruct the relative frequency table based on the information that we still have, these entries over here? Now, I'll let you think about it for a second. Pause the video and think if you try to see if you can do it. Okay, did you think about it? It might seem to you that there's not enough information. So why do I say that? Because, for example, let's say I wanted to figure out what should go in this blank space over here. Well, I can't do that because there's also missing information in that same column. So I can't figure out what this blank spot, what should go in this blank spot based on the information that I have in this column, because there's another spot, there's another blank spot in the column, and I can't figure out what it should be based on the row either, because again, if I look at the row that this is in, there's another blank spot in the row. So it looks like, and it's the same thing for all of them. I can't figure out what this is by looking at the rest of the column because there's another blank spot in the column, and I can't figure out what it is by looking at the row that it's in either because there happens to be another blank spot in the same row. By the way, I should have mentioned this way earlier, but columns are vertical and rows are horizontal. Hopefully, when you heard me say column and you also heard me say row, hopefully you figured that out based on the context that I was using it in. But anyway, columns are vertical, rows are horizontal. Back to here, there doesn't seem to be enough information for us to complete this table, because every time that we try to figure out what goes in a blank spot, there's another blank spot in the same column or the same row. But actually, there is enough information for us to figure this out. And the trick that you have to remember is that this bottom right corner here, which gives us the grand total, in a relative frequency table, it's always 1. Because the grand total is always 100% of whatever it is we're talking about. I mentioned that earlier in the video. So the grand total in a relative frequency table should always be 100%, or in decimal form, 1. And once I filled that in, then I can see there actually is enough information for me to fill in the rest of these blank entries. And I would use the same logic that I used earlier when I was filling in the normal frequency table. We had a similar problem earlier in the video filling out a frequency table where some of the entries had been deleted. We're going to do the exact same thing. So what would this entry be? I can figure that out just by doing 1 minus 0.56, which would give me 0.44. Okay, and then we can double check that that makes sense, because 0.44 plus 0.56 is equal to 1. Remember, this is supposed to be the grand total of this and this. Okay, what should go over here? Well, we can figure that out by doing 1 minus 0.22 and then minus 0.28. And that would be 0.5. but I just want to show you what I'm doing. So it's 1 minus 0.22 minus 0.28. You don't actually have to put the 0 in. Well, if you're doing the activity in Deck Toys, then to put in the answer, I always make it so that you have to put 0 point something. You have to fill in that 0 if you're doing one of my activities in Deck Toys, but you don't have to do it in the calculator. And we would get 0.5 over here. Okay, and we can just continue doing stuff like this until we figured everything out. Okay, so let's see, what else? 0, to figure out what this one should be, well, I know that this plus this must be equal to this, and therefore this minus this must be equal to this. So 0.5 minus 0.2 gives me 0.3. And let's see, what else can we figure? What about this one over here? So I can't figure this out yet based on the row because I still have a blank spot in the same row, but I can figure it out if I look at the column that it's in. I filled out everything else in the column. So to do this one, we would do 0.56 minus 0.3, which would be 0.26, and then minus 0.14, which would be 0.12. Okay, let's see, and 0.28 minus 0.12 would be 0.16. Okay, and then let's just double check that this makes sense. This should be the total of this and this. So 0.16 plus 0.12 is equal to 0.28. Now, what if we had something like this, and then rather than figuring it out by subtracting, is it possible to figure it out using addition? It is. If I don't know what the total is, but I know what these entries are over here, then I could say that 0.2 plus 0.3 is equal to 0.5. So if you don't know what a total is, then you have to add up the other numbers that are in the same row, or sometimes in the same column, maybe. But if you don't know what one of these entries are over here, then you have to use subtraction to get them. Okay, it's also sometimes possible, like I did earlier, to figure out a total by using subtraction. Like I did 1 minus 0.56 equals 0.44. Okay, anyway, so I'm going to move on now. So this is pretty simple to fill that in. All right, let's go down here where it says Gary the golf guy and Patty the pro are in a contest to see who the best miniature golf player in the universe is. And apparently it's only between these two people. They will randomly pick one hole to compete on. All right, so here's, this is the same table that we had earlier. Okay, here are the courses here. Goofy Golf and Perfect Putt, here are the difficulties. What is the probability that the hole they pick is from Perfect Putt? So let's answer some probability questions. Now you can give a probability in decimal form or in percent form, but I'm going to be giving all of these probabilities in fraction form. So I'm going to be putting, well, let's just do some. So what's the probability that the hole they pick is from Perfect Putt? Okay, so I have to ask myself, how many holes are there in the Perfect Putt golf course? And that is 28. There are 28 holes in the Perfect Putt golf course, right? That's the total of all the beginner, intermediate, and advanced holes. So there are 28. I'm going to put that in the numerator, and in the denominator, I'm going to put all of the holes that there are, okay, which is 50. Okay, so if we were to just pick a hole at random for these two people to compete on, the probability that we pick a hole from the Perfect Putt golf course is 28 out of 50. Okay? All right, let's move on to the next question. What is the probability? And you know what? I'm going to split the screen here. I'm I'm going to keep this in the top, and we'll do the questions in the bottom. Next question, what is the probability that the hole is an advanced goofy golf hole? Well, let's ask ourselves, how many advanced goofy golf holes are there? There are 10 advanced goofy golf holes. 10 of the holes from the Goofy Golf Course are at that advanced level. So I'm going to put that in the numerator, and again in the denominator I would put the total number of holes all together, whether they're from Goofy Golf or Perfect Putt or beginner, intermediate, or advanced. There are 50 holes all together. That's our grand total. So that would go in the denominator. Okay, so that's our probability. The probability that the hole they pick at random is an advanced hole from the Goofy Golf Course is 10 out of 50. All right, next question. If they decide the hole must be beginner, what is the probability it will be from Perfect Putt? So this one is a little bit trickier. In the last two problems, the denominator was always the grand total. But in this problem, for whatever reason, Gary the Golf Pro and Patty, what was her name? Patty the Pro. No, Gary the Golf Guy and Patty the Pro, for whatever reason, they decided that the hole they want to compete on must be a beginner hole. So now in the denominator, we're not going to put the grand total 50. We're just going to put the total of all of the beginner holes. So here are the beginner holes in this row. The total is 14. That's what we're going to put in the denominator this time. Now, what's the probability if we only look at the beginner holes that it's from Perfect Putt? Well, 6 of these beginner holes were from Perfect Putt. So we're going to put this number in the numerator. Okay, so if we're only looking at the beginner holes, then the probability that the hole is from Perfect Putt is 6 out of 14. All right, and we could reduce that. Oh, you know what? I should have reduced the other ones, by the way. Let me practice reducing these. Let me go up here. The hole they pick is from Perfect Putt. That was 28 out of 50. So what's a common factor between 28 and 50? What goes nicely into 50 and also into 28? How about 2? We can divide the numerator and the denominator here by 2. Okay, and we would get 14 out of 25. So that would be the probability in reduced form. We cannot reduce it any further than that. Okay, so there's the probability in reduced form, and this fraction is equivalent to this fraction. If you were to do 14 divided by 25, you would get 0.56. If you were to do 28 divided by 50, you would also get 0.56. So these fractions are equivalent. Let's answer what was the answer to this one? The probability that the hole is an advanced Goofy Golf hole, that was 10 out of 50. Can we reduce that? Yes, we can. Both of these numbers are divisible by 10. So 10 divided by 10 is 1, and 50 divided by 10 is 5. So our reduced fraction for the probability is 1/5, okay? And by the way, if you didn't, off the top of your head, if you didn't think or realize that both of these numbers were divisible by 10, then you could have worked it out this way. Maybe you did realize that both were divisible by 2. Well, then you could say that this is equivalent to 5 over 25. 10 divided by 2 is 5. 50 divided by 2 is 25. And then you could reduce this further. Both of these numbers are divisible by 5. And we would get 5 divided by 5 is 1. 25 divided by 5 is 5. So just keep doing this until you can't reduce anymore. And you would get the same answer that you would have gotten if you had reduced originally by the greatest common factor, which in this problem was 10. Okay? All right, and notice also that 2 times 5, the numbers that we divided by here, 2 times 5 is 10, which is the greatest common factor that we used earlier. Okay, so going back to the third problem, which is what we were on. If they decide the hole must be beginner, what's the probability it will be from perfect putt? So that was 6 out of 14. And we can reduce this and this by 2. And we would get 3/7 as our reduced probability. Now what about this question over here? If they decide the hole must be from perfect putt, what is the probability it is beginner? They have to be careful here. This question is not the same as this question. Both of these questions mentioned beginner difficulty level, and both of the questions mentioned that the golf course they wanted was perfect putt, but these questions are not the same. For this question, they decided that the hole must be beginner, so we were looking at the total number of beginner holes. For this problem, they have decided that the hole must be from perfect putt, and therefore we're going to begin by looking at the total number of holes from the perfect putt golf course, which is 28. Okay, so if they pick one of those holes at the perfect putt golf course, what is the probability that it is a beginner hole? Well, there are 6 beginner holes at the perfect putt golf course, 28 holes total at the perfect putt golf course. So the probability that the hole that they choose is a beginner hole, assuming that they only want to choose holes from the perfect putt golf course, is 6 out of 28. And we can reduce that. Again, these are both divisible by 2. It's not always 2, but both of these happen to be perfect even numbers. So 6 divided by 2 is 3, and 28 divided by 2 is 14, which is not the same answer we got earlier. Remember, the answer we got earlier was 3/7, not 3/14. Okay, so this time we got 3/14. All right. Notice also that this probability is not as large as this probability over here. 3/14 is less than 3/7, right? So there's less of a chance that if they already go into it knowing that they want to play at perfect putt, there's less of a chance that the hole they pick is a beginner hole, as opposed to if they already knew that they wanted to pick a beginner hole, the chance that it would be from perfect putt is only 3/7, which is actually a greater fraction, so it's a greater probability. They have more of a chance of this happening than of this happening. Okay, so that's it. I'm going to end the video there, and have a great day.